The broadcast is now starting. All attendees are in listen-only mode.
Good morning, and this is Andy Ebb speaking, and I apologise if it's a slightly late start here. We should be able to start any second. I just can see there's still a couple of people still joining, so if we could just give it a minute or so. But today's webinar is going to be on Carbonite Migrate, although I think I probably need to update my slide to say Carbonite Migrate rather than an overview on the Carbonite products, but the slides we're going to look at today are going to focus on migration, and particular migration to any cloud. So replicating from a physical or virtual environment or even another cloud environment into a public cloud such as Azure or Amazon or Google Cloud or Huawei or anything like that. I think it looks like it's quieting down as far as people joining. So I think as we're 2 minutes past already, I think I'll start the presentation. So just to remind you, my name is Andy Ebbs. I'm a pre-sales engineer based in the UK, covering Europe, Middle East, and Africa. I work with all sorts of sizes of organizations, and CMS is one of our main distributors. I think they are our main distributor for the UK. And we work with the reseller channel, and we help promote our product and make sure that it's easy for you guys to enable your users to migrate as easily as possible into the cloud. If I can step onto my next slide, I just wanted to quickly explain who Carbonite is. So Carbonite, it's a bit confusing at the moment because we're going through a bit of a transition. So recently Carbonite was acquired by OpenText. So you might see some of our emails and so on referring to us as OpenText. It's a Canadian company that acquired us in December of last year. So all that integration is happily going along at the moment. And OpenText, large software company based out of Canada, about 15,000 employees now, and we focus on information management. Carbonite was acquired because Carbonite has this strong message of protecting servers by preventing malicious code from being downloaded, and also backing that data up and providing high availability for it. So we have quite a few different products in our portfolio. You can see the Carbonite stuff there. We have an endpoint tool for backing up laptops and desktops. We have a backup for servers and for Office 365. And we also provide this availability, migrate, and recover. Now I'm going to focus on migrate, but these three products are basically the same. They're just different licensing types. You might be wondering who WebRoot are, but I know WebRoot is quite a big, strong partner already with CMS. And WebRoot is a product that was acquired, or a company that was acquired by Carbonite about a year ago. So the merger between Carbonite and WebRoot hadn't finished before Carbonite was acquired by OpenText. So it's all getting a bit confusing, but we are integrating, and we are going to be able to provide this message of cybersecurity. So this is protecting your users from downloading malicious code by blocking the endpoint from people downloading malicious code, by training the end users using security awareness training. That's really clever stuff. Blocking DNSs, DNS paths to dodgy websites or dubious locations where they might get phishing software accidentally downloaded. It's all done with this AI Bright Cloud environment. And then there's also antivirus as well. So maybe you guys already know us as WebRoot, maybe you know us as Carbonite, but now we're part of the OpenText company, and this focus on preventing something from maliciously getting onto your server. If something happens, then we have tools to provide high availability or get you back online again. Having said that, we're going to be looking at migration today, which is using the same tools but in a slightly different way. So I want to focus on Migrate today, so I'll just skip past the last slide, and we're looking at Carbonite Migrate. And Carbonite Migrate is this tool that allows you to migrate from physical virtual cloud to physical virtual cloud. So we have this any-to-any tool. Originally it was high availability, so the scenario would be you'd have a live SQL server. We would replicate that to a second location, and in a disaster you'd fail over to it. But if you think about it, a migration is basically the same thing. It's just managing that process, being able to synchronize the data, get it in sync, and then cut over. And if you can do that rapidly, that's where we're reducing the amount of downtime and also taking the risk away, because we can get the data there, we know it's there, we can do some testing before we do a managed failover of that data. Carbonite Migrate has a couple of different workflows. We have one which is called, and I don't know if this is maybe blocking the data here. I'm just clicking the wrong buttons and go to webinar here. Oops, wrong one again. Quite sure which is actually to hide. Oh, it's this one here. Okay, so we've got Carbonite Migrate Center, Carbonite Cloud Migration Center, which is an automated tool. We have a SQL migration workflow, which I'll maybe touch on later in my slides. But generally, we're going to be using Carbonite Migrate as an ability to run a single console that you could use to go to Azure, you could use to go to Amazon, you could use to go to Google Cloud or Huawei Cloud, or Alibaba, or even any cloud whatsoever. I'm struggling with ones now to think which ones you can use, but there's things like the SoftLayer, IBM's cloud, Fujitsu cloud, even the OpenText cloud. That's an important one I should probably mention now, because OpenText have the cloud of their own. So we have this any-to-any. We have a very efficient way of replicating the data. I'll show you a slide in that in a second. We have a very easy to use console. Again, I'll show you that in my demo coming up. We have security, the ability to encrypt the data as we transmit it from your live environment to your new target environment. And then the support. There's 24/7 telephone support. We have engineers in the UK who will help you out if you get stuck. We have global support, so we have sites globally who, if you're outside of office hours in the UK, it bounces to maybe the US or Malaysia or somewhere like that. There's also training courses, and we've also got professional services, so we can actually do the whole migration from discovery through to the actual the failover and manage the whole thing for you if that's what you need. So I keep pressing the wrong button, and it's just pop this thing back up again. So let's hopefully move on to the next slide. So this is how we actually replicate data. So we have this engine that's going to be used whether we're going to Amazon, Azure, whether we're going to HyperV or VMware, or even if we're doing physical to physical, the same replication engine. And this is core to our product. It's very unique. It's our own method of replication. We're not using snapshots. We're not using block level. We're actually using agent-based file level replication of the file system on your production server. So if you imagine you've got a production server, we have an application layer. In that application layer, you're going to have SQL, you're going to have Oracle, you might have SharePoint, could be a domain controller. We don't really care what the application is. What we're going to be interested in is the changes that application is making to the actual operating system files. So we see those changes come down through the stack, that instruction to open an SQL database and make a change. We capture that transaction. That's what we're going to be replicating to the target. And we sit in the operating system using a filter driver, that's our agent, and it's able to see these changes as they come down through the actual Microsoft I/O stack. So we see them before they actually get to the disk. So the type of disk is sort of irrelevant to us as well. So it could be iSCSI, Fiber Channel, SATA, SAS. It could be VMDK or VHD. We don't really care because we see the C drive, the E drive, the F drive. We don't see underneath that level. But that gives us a lot of flexibility because it means we don't have to replicate every file and folder on that machine. We can choose just the files and folders that are important to us. So the system files, maybe the SQL databases, particular file shares. We can make exclusions, swap files, temporary directories, and so on. So we start by mirroring those across. That's our initial seed of the data. That is differential. So if you've got it on the target, we'd have to send it again. This is a bit that takes a bit of time. It might take a few hours, might take a few days if you've got a slow network connection, a lot of data to synchronize. But we're able to do this with live open SQL databases, live open Word documents, whatever's running on that production server. And we can do that because we have a second process, which is our replication running at the same time. So mirroring and replication. Mirroring gets the baseline copy of the data. Replication captures all the new stuff that's happening in real time. And that's where we're interested in capturing that data as it comes down through the stack. We branch off a copy. We wait to see that it gets written to disk because we need to make sure the changes that we're replicating match the data that we've been mirroring. And then when we see that acknowledgement come back at the stack, we can replicate the change over to the target machine and rewrite it to the target. Now, I'm racing through this because I know I've got a lot to cover in this half hour I've got scheduled here, and I do want to get to the demo and show you a failover. But, I can go on about this for hours, and it's fundamentally what's different about our tool than our competitors and, even the Microsoft solutions that do similar sort of replication on paper, but in the background, we're doing this in real time at byte level. So we get the data in sync, we keep it in sync, and then we will fail over to that data. And generally, the recovery point objective, I suppose that's more important with high availability, but that's what our tool does, is seconds. We have a very real-time copy of your data onto that target. We've also got tools to be able to handle intermittent bandwidth. So if you've got perfect bandwidth, you know, the data's seconds out. But if it's a slow network connection, if it's got lots of other traffic on it, if you want to actually limit it, we can throttle the amount of bandwidth that's available to double take. I'm calling it double take because I maybe should have explained this earlier, but double take is what Carbonite Migrate used to be called. So Carbonite availability, Carbonite Migrate, Carbonite recover, that used to be known as double take before the technology was acquired about 4 years ago by Carbonite. And I still call it that, and you'll still see that if you see our demo in a second, there's mention of it as well. But essentially, it's the same replication engine, and then Carbonite have enhanced the workflows and added some new functionalities, which is what I was going to demonstrate today. But what I was saying is we can queue the changes if we can't send them immediately, and we can force that queuing to throttle the amount of bandwidth if that's what you need as well. But we queue to memory, and if necessary, queue to disk. So if you've got a slow network connection, if you've got a site with limited amounts of bandwidth and you want to restrict it during office hours so that you're only mirroring in the evening, then that's what we can do. And when we do get enough bandwidth, we'll send that data over to the target. We get it in sync. But the important thing is it's very quick for us to do that because we've only maybe got a few transactions left in the queue when we come to failover. So that's what the replication does. As I say, I can go on and on and on about that one, but I'm going to just move on to the sort of workflow that we're going to focus on today. So this is what we call full server migration or protection. This is probably the last slide I'm going to show you in my PowerPoint deck. I might come back to this in a minute once I've actually shown you an actual failover or during the failover process, because that can take a few minutes. But if we're going to a target environment where we don't have access to the hypervisor, so that means if we're going to physical or we're going to public cloud or private cloud, or maybe you're going to a VMware environment, you don't have access to the target hypervisor because it's a third-party VMware environment and you can't access the vCloud and so on. Well, this workflow will work. Now, on the source end, we really don't care what it is. It could be physical, it could be virtual, it could be VMware, as long as we can install our agent onto the production server. So if you've got a site at the moment using a third-party data center, it might be running VMware, it might be running Zen or KVM, or it might just be physical, it could be HyperV. Doesn't really matter. As long as we can install our agent onto the virtual machines, the physical or virtual machines, whether they're Windows or Linux, then we're going to be able to replicate the data. And the way that we do this is we need a target machine. So you need to be able to provision the same Windows or Linux version on the target, and it needs to be the same release of Windows. So if you've got Windows 2012 R2, you'd provision a Windows 2012 R2 target machine with just a plain base OS. You also need to provision the same drive letters, so CEF on the source, you need CEF on the target, but the hardware can be completely different. So, this could be a physical Dell machine, this could be a HyperV replica virtual machine, which in effect would be if it was in Azure, or if it was in Amazon, it would be a Zen virtual machine. We don't really care what the hardware is, it's not sort of important to us. What we then do is we replicate the system state. So that means that we're going to replicate the Windows directory, the program files, a copy of the registry, a copy of the user directory, but we have to put it into a temporary location. We call that staging folder. So on this target machine, on the C drive, you would see a folder called staging, and in that subdirectory, you would see a copy of the Windows directory from the source, a copy of the program files, a copy of the user directory. You'd see this as a live copy of those files and folders. So if you patch or hotfix the source machine, those changes would be immediately reflected in that staging folder. We have to put them there because this is a running Windows operating system, so you can't overwrite live system files, as I'm sure you all know. The application data, that can be replicated at the correct path. So if you've got e:/data full of SQL files, or maybe it's a file share, you can replicate e:/data on the target because we don't need you to install SQL. You don't have to set up any file shares or anything on the target. So there's no conflict there. So the data can go to the correct path on the target without having to sort of worry about blocked files or files being corrupted or anything like that. So we start synchronizing the data, we get it in sync, we keep it in sync until you have a few minutes to manage your actual failover. So we could maybe install on a Monday, no reboot. We can synchronize Monday, Tuesday, Wednesday. The users remain connected Monday, Tuesday, Wednesday because we're replicating all the real-time change. Wednesday afternoon, the data's in sync, and we could then fail over immediately or cut over immediately. That's the migration term, I suppose. We could migrate, cut over immediately on Wednesday afternoon, or we can just keep replicating the new change, the deltas, until Friday, or maybe a couple of weeks later when you've got some scheduled downtime, because this is going to take maybe 10, 15 minutes. So what we're going to do is trigger the source machine to shut down. We wait for any last changes that are in the queue, potentially just a few seconds of change. And then we can start moving the files from the staging directory over the top of the plain Windows operating system. I use the word move there rather than copy because it's quite a quick process. We're just basically moving, not copying. You know, it's quite quick. Just takes a minute or two. Then we merge the registry settings from the source with the target. When we do that, we discard the hardware references in the registry. So any references to Dell hardware get discarded, and we keep the ones for the Zen or Hyper-V virtual appliance if we're going to Amazon or Azure. We keep that data, the actual software system layer intact. So all the applications and Windows configuration settings in the registry, that all gets merged to the target registry. So that's how we get the applications across, and we can go to different hardware. The machine then gets rebooted, but after a reboot, it becomes a clone of the original source machine. So it's going to have the same host name, the same security ID, the same applications, all the same configuration, basically. The only thing we might change is we would usually fail over, but keep the target machine's network configuration. So if you're going to Azure or Amazon, we keep the configuration for we'd keep the configuration for the networking on the target Amazon or Azure virtual machine, so you can connect to it afterwards. So this is a fairly, hopefully, straightforward process. There's a reboot, but you know that's how it's going to work. We don't really care what the target environment is. If it goes horribly wrong, you just turn your original machine back online. But you know, in general, most servers are going to fail over, you know, reliably every time. And you know, we're talking about 10 or 15 minutes for this complete. If you compare it to something like VMware Converter that you might have used before, you know, that might take, you know, half an hour to synchronize the last few changes once you decide to press the button, and then it might take half an hour to do the conversion. So, you know, this is a lot quicker. It's a lot more repeatable, and you know, it's easy to do, you know, trial runs and things like that as well. So I'm going to try and show you that now in my demo lab. So if you bear with me, I'll just switch over to my virtual machines. So I've switched over to a demo environment. I've got a couple of, this is the Carbonite replication console. This could be run anywhere on your network that can see the source and target machines. We talk about it being, you know, as long as it can connect over a couple of ports we need open. In fact, for the console, probably just the one port, 6320. As long as you can connect to the source machine, we can connect to the target machine. You could run this on your laptop, on a desktop, on a virtual machine. To keep things simple for this demo, to stop me having to switch between virtual machines all the time, I'm actually running on my target machine. It's called Carb Target, and you can see that's Carb Target. I'm going to be replicating to. That's going to be my double take target. And my source machine is it's you know, it's another machine, another virtual machine. I can actually switch through to that one. You can see it's a live server, and I'll maybe just create a file on this here just to show you it's a live server. So I'll maybe just call it CMS. We'll just save that file. And if I just bring it down here, make it a bit tidier. So this machine, as I say, at the moment it's Carb Source, and its Carb Source is the RDP connection I've got to that. Just to make it a bit clearer as well, I am doing public cloud here. In fact, today's demo, I'm going to be using two machines. And you can see there's Carb Source and Carb Target. These machines are both running in Azure. I've actually got a few different servers here, but the machines we're looking at here are these two here. So currently they're both running. Everything else in my lab is stopped. So I'm going to actually go Azure to Azure. I'm being a bit lazy. I could have gone Amazon to Azure, but I have to open a couple of ports. And for the case of today's demo, just to show you, give you a flavor of it, that's how it actually works. So that's my source machine. So we'll go back to the target because I want to show you the console. I've added my two source machines. You just add them by clicking add. I apologize for a bit of noise. Obviously, it's quite hot today. You might have noticed. I'm sitting in my conservatory with the conservatory doors open, and the train's just gone down the back of my garden. I'll be done in a second, hopefully. But I can see I've got a option here to add the server, my name. I can have a username and password, domain, and then just add these machines into a list of servers. It's easy to add multiple machines. You've got different tools for doing that. Once you've got them in here, you can administer them centrally. You know, I can edit the server properties. I can view their logs. I can view the replication service detail, a lot more detail. But I can also choose to migrate. So that's what I'm going to click on here. So I click migrate, and I get a wizard now. And the wizard allows me to choose what data I want to protect. So I could choose just individual files and folders. You know, if I was doing a file server, it's quite useful. I can use this, I can actually go between different versions of Windows. So I could go from Windows 2008 R2, I could replicate some file shares to Windows 2019 even. But I can't migrate the applications that way. This is data only. But we might do that for SQL, so we can go from an old version of SQL to a new one, and that's what we call SQL modernization. And if I've got time today, I'll show you a slide on that because it's quite a popular workflow we do. We're going to use full server full server migration, but we do also have another one. If you're going to ESX, going to Hyper-V, we can do a bit more automation. Again, I'll try and show you a slide on that if we've got some time later on in the demo. But I'm going to choose full server migration. You can see these are the replication rules, and I'll maybe just make this full screen. So these are my replication rules. It's basically, if I expand that out, you can see it's going to do all these green folders on my server, but we can exclude stuff we don't need. So because it's an Azure virtual machine, it knows that these have just got temp files that aren't going to be much use to me. And it's built these rules. You can see them summarized at the bottom, everything on the C drive, including all the subdirectories. So recursively the subdirectories, but we exclude the recycle bin. We need auto-exec back because that might have some configuration files. And we don't want the boot files and so on. There's a whole list of these, but the wizard builds these, so you don't have to worry about it. We know basically what you want. But if you didn't want, say, the registry dump, you could select that directory, you could choose to exclude it, and you could add a rule. But obviously, that's quite important stuff, so I'm not going to exclude it, but you can get the idea. I then click next, so I can choose my target machine, so there's that carb target machine. And then I click next again, and I'll get some options. So these options are going to allow me to customize the job a bit, and most of them I'm going to leave it default. But I'm just going to point out the obvious ones for when you go into the cloud. Now, there's the name of the job, what it's going to be called about. This is the thing that allows you to wait for you to make the change, make the decision you want to cut over, because otherwise it's a bit unpredictable. So normally you want to say, I want to fail over now. We're going to shut down the source server so we don't end up with 2 live servers on the network at the same time. That's optional because you might want to do some advanced testing. So you might want to do a trial run, but fail over to a private environment. We can run scripts as we fail over and fail before and after failover, I should say. We're going to retain the target machine's network settings because we're going to fail over to a different subnet. So we need to be able to configure that. So we keep the target machine's network settings. And if you've got DNS, we can update the DNS records for you as well. Most of these other settings, we would use the default. So things like the mirror settings, the root to the network, the staging folder, the target service and everything. I don't need to change those. But I might turn compression on. We've got 3 levels of compression because the more compression, the higher the CPU overhead. So there's a bit of flexibility there because compressing means additional calculations. So you're going to have a CPU overhead. Normally, our agent isn't noticeable running on a server, but if you turn compression to high, you might start seeing 5, 10%, maybe 15%, depends on the server. Because we're quite effective at this, and it'll halve the amount of data that gets sent over the network. But it's intelligent. It can see the files, the JPEGs, MP3s, zip files. So if you can see those files, it knows they're already compressed. It doesn't waste time trying to compress them. So it's worth turning on. I'd normally set it to medium and then increase or decrease it depending on performance on the server. I think I've set my demo I've already configured to maximum. You can see there's things like the throttling. So this is where you can have a schedule on the amount of bandwidth available at different times of the day. I'm going to click on next again, and this validates to make sure that the settings are acceptable and they're going to work successfully for your job. You can see there is an error message, and that's because I've already configured this job Blue Peter style, so I've made the job earlier. So it's just telling me that because you can't obviously configure the same job to the same target twice. That just doesn't make any sense. But it's checking to make sure ports are open, that there's the right versions of the operating system, and the right volumes and things like that. I'd normally be able to click finish here. If I wanted to, I could kill the original job and I could recheck and it would all go ahead. And then I click finish, but I'm just going to click cancel and take you to the job screen instead. So here's my job that I created. Just expand that out a bit. You can see carb source, the carb target, source is carb source, target's target, and you can see it's a full server migration. It's all protecting and idle, and some of the terminology here is because this can also be used for high availability as well, and it quite often is. So if you want to protect from Amazon to Azure in case you're worried Amazon goes down, or vice versa, there's in the UK, wherever most of you guys are going to be, I know, started for everybody working from home, Teams was given more priority, and I had a lot of demo issues with my virtual machines not being able to allocate when I started them up in the mornings. in Azure because Microsoft had reallocated resources, and I'd have to try a few times before I was able to start virtual machines. And you might be concerned that performance might be impacted on your Azure environment adversely because of unpredictable factors like we've had at the moment. So this gives you the ability to maybe protect machines into Amazon or vice versa. But we're going to work through this one here. So I've got the migration. You can see some of the stats here. Because I'd already gave this demo up previously, it was able to resynchronize, but skip 5.3 gig of data because it was already on the target. So in the end, it only sent 11 gig. With compression, it actually only sent 6 gig. So, we're quite, 5.8 gig, we really managed to reduce the amount of data that gets sent over the network. Before I do a failover, I just wanted to show you, I'm on the target machine. So what I should be able to show you is I've just got up the file browser on this machine. If we look at the C drive, you see there's that staging folder I referred to earlier. If we go into staging, I can see the files, and I can see program files, users, windows, and so on, as I said. I can go to Andy, which is my user profile. I can go to desktop, and we should see that file, that CMS one that I created. But that was replicating in real time. I just want to explain, this is not scanning the file system periodically and saying, make that change. If I modify that file, and we'll maybe just say CMS demo, and commit that change, by the time I go back to the source machine, that change will have propagated across. So you can see there's that file. So, the replication is real time. If we see a change on the live server, we immediately send it to the target. So we're fractions of a second out if you've got a reasonable network. And this is the same for SQL database. Oracle database is just a bit more difficult for them to show you that happening in real time. So I'm just, showing you a flat file, I admit, but, it would be the same for live databases and so on. So we're now ready to do a cutover. So I'm going to be brave and do that. I was watching Tomorrow World on YouTube the other day for something else. Live demos never is something you try and avoid, but I'm going to try this. Generally our software is very reliable. So I'm going to cut over live data. I do have these options which are more related to my high availability, some of the other workflows I do. And I'm going to click cutover. Now the time is now it's 10:28 in the UK. So I'm going to click failover. You can see the failover command's been issued. The first thing we'd notice is my source machine's just gone offline because we shut that machine down. And then the conversion process sort of takes place, and it's going to take it probably 5 to 10 minutes. I mean, it varies a little bit depending on how busy Azure is and what processes are running on the source machine when I click the failover. But in my demo lab, it's normally that. In the real world, you're probably looking at it taking 10 to 15 minutes because you've probably got a slightly more complex server than my demo lab I'm using today. And it might even take longer. It depends on what's running on the target. But I'd recommend disabling antivirus and Windows Defender on the target because these can slow the process down because they're constantly looking at the changes we're making. So while that's just doing that, you can see it's at 9%. So what's going to happen is it's going to get to 100%. This machine will restart. So I'm going to switch over to my PowerPoint deck just to show you a couple of workflows while we're just waiting for that to happen. Although what I might actually, let me show you another workflow. So the other one I wanted to show you was full server to ESX. If you've got a hypervisor like VMware or HyperV, then we can do it a little differently. It replicates many servers, so multiple, many to one virtual recovery appliance. And this is basically a proxy or a middleman server that we can replicate to instead of having, if you've got 10 servers you want to migrate, if you go into the cloud, you have to provision 10 targets. That's not a problem for Azure. Amazon, you just say create 10 machines. You could do it with PowerShell or something like that with the correct operating system. But if you're going to your own VMware environment, your own ESX environment, it might be a pain backside to do that because you might not have templates of different operating systems, especially older ones. So what this allows you to do is we run through a wizard, looks at the source machine, sees the operating system, and then provisions an empty virtual machine. So it creates the VMX file, creates the VMDK files, and then this virtual machine that we've provisioned stays offline. And what we can do is we can attach those virtual hard disks to this temporary machine, this virtual recovery appliance, and then we can present those VMDKs as virtual SCSI devices, present them to the Windows operating system as Windows mount points, and we can replicate from the C drive straight into those VMDK files. So we replicate the whole operating system, all the data volumes and so on. And we do that for multiple servers. We get the data synchronized across, and then when you're ready to do your cutover, all we need to do is disconnect the disks from the virtual recovery appliance, and reattach them to the virtual machine and start it up. So that's why I say, if you go into ESX, you go into Hyper-V, we can do it a lot more quickly, usually, 5 minutes of downtime or less, rather than like 10, 15 minutes. It's also quite easy to test as well. So, bear in mind, we don't have to provision the targets if you're going to VMware ESX. The other slide I wanted to show you, if you've got lots of machines to go to Amazon or Azure, then we have this thing called Cloud Migration Center. It's a slightly different automated wizard. You go to a website, it's migrate.doubletake.com. You create an account on there with your own credentials so you can save your settings. And then we have the ability to discover machines in your live environment, where it's physical, virtual, cloud. We can push our agent out into those machines. We can discover what sort of process account, memory, version of Windows, and automatically suggest suitably sized machines in Amazon or Azure. So we work with the templates that Microsoft or Amazon provide, and you can then choose the suitable size. Would recommend what size, but you can increase or decrease the size. Push the agent out to those, provision them, push the agent out. Then we create a full server job in the background. So it's automating what I've been showing you today using a web interface, and it allows you to select a group of machines to migrate rather than just going through this individually for your server. So if you've got 100 machines, it could really save you a lot of time. We don't charge any more for Cloud Migration Center. It uses the same license keys and so on. And that was basically it on the slide. So I'm hoping that we're getting close to, it's probably going to be another couple of minutes. As I said, it's taken 4 minutes so far. I would expect it to take hopefully about 6 or 7 minutes, but it might take up to 10. So what I'm going to do is I'm going to check if there's any questions. So bear with me. I'm not that familiar with GoToMeeting. So I'm just going to try and check if there's any questions in the chat. I'm not seeing any, but hopefully you guys can see the chat window in your settings here. So if you've got any questions, please fire away with any questions. I'm also hoping that there are still people online. It looks like, yeah, plenty of people still online. So if you have any questions, please type them in the chat window and they'll pop up my screen, I hope. If they don't pop up on mine, they might pop up on Laura at CMS's. So while I'm just waiting for this, because I don't want to keep you all too long, consider it's 74%. So if you guys are interested in this, and I'm hoping that I haven't just put you all to sleep, and the reason there's no questions is I've been totally clear and it makes lots of sense. If you've got any questions, just drop me a line. My email address, I should have that at the end of my slide deck. It might need updating though. I'm terrible for keeping lots of different, so you've missed out on lots of really good slides here. No, you still use aebs@carbonite.com, but in fact, you could also use aebs@opentext.com, which is my current new email address. So if you get emails from me, it'll be from OpenText, but I'll still contactable on carbonite.com. So just drop me an email, speak to your account manager at CMS, and they'll be able to put me in touch. You can see that machine's just powered off. So that was my carb target. It's just connection's been lost because the machine's just been rebooted. I just give it a second before I try and connect back into it. But you can see that's really it now. The migration is completed. It was about 6 minutes. I'm going to try and connect to carb target again now. So I'm connecting to carb target's IP address. It isn't quite back online yet. But I'm sure you've rebooted machines before. You'll know that IDP isn't the first service to start, so I might need to try reconnecting. Oh, it's let me in the first time. So it's now logging me into the desktop, and straight away we can see there's that CMS demo. And if we look at the local server information, we can see it's carb source, so that's the host name. But we're still running on the carb target machine. So that's a migration, even with the reboot, less than 7 minutes. I think that's hopefully impressive. It should be quicker than the other solutions you probably see out there, including Microsoft. I appreciate it has ASR, but you have a lot of prerequisites for ASR. If you're doing physical machines, you have to start setting up machines to actually handle the migration, and they have requirements of disk storage and things like that. If you're going from VMware and Hyper-V, you have different environments to set up. You can use this workflow to go to Amazon as well. There's no difference really, apart from you putting the IP address of your Amazon machine and provisioning machines in an Amazon environment. So, one product to learn, one solution to learn. And, it's pretty painless. Yeah, so I think from my point of view, that's really it on the demo. So I would like to thank you all for your time. I'm sorry I've run over by about 6 minutes so far. If you do have any questions, as I say, email me, aebs@carbonite.com or aebs@opentext.com, preferably. Speak to your account manager at CMS. If you want to have a play around with the software, there's evaluations available. If you've got colleagues who want to talk about it or see some more about it, maybe I've got your interest today, happy to set up specific demos or presentations for them. There will be a recording of this demo, I believe, circulated after this call. And there are trial licenses, so if you want to have a play around with the software, make sure it does what you want it to, and it's as easy as I'm showing you here. You know, drop us a line and we'll be able to sort that out for you as well. But that's it from me. Thank you very much. I don't know if there's any last points from CMS or from my marketing team. There's a few other people on the call. If not, I'm going to call it a day and say thank you very much for your time. And
Thanks,
speak to you again soon.
Andy,
Thanks,
so
Andy.
we do have one question that's just come up. Is the cloud migration free?
The Cloud Migration Center, the tool, anybody can go to this Cloud Migration Center, and yeah, it's a free tool. All you need to do is go to, but you need to have a license of our software. But if you go to migrate.doubletake.com, and you'd be prompted to create an account, and when you create an account, you'd be able to log in, and it's just it's a web console rather than the console I've been showing you today. But you can see it's designed to support Amazon, Microsoft Azure, the different environments. You know, can even do Azure Classic. I don't think anybody's still using that. But we are going to be enhancing this. We'll be adding other clouds like Google Cloud's being worked on at the moment, vCloud, and things like that. If you got a private cloud, and we have different environments you'd add into. You'd add in your Amazon or Azure or the different source environments and target environments. And then it has the ability to discover servers in those platforms. So you can see these machines were found in my Amazon environment. I could just tick the machines I want to migrate, and then you can just click migrate. And it's not going to work because I haven't set this up for today's demo. But this is where you put demo and choose your target environment and so on. So it's designed to allow you to protect lots of servers in one go. But you still need to use a Carbonite Migrate license, and you see where those are added in here. The only difference really is you'd need to be using an older license. So the current version of Carbonite Migrate is actually 8.4, but this engine actually uses 8.3 licenses. So I probably need to get rid of these. And that's one of the reasons I haven't set up today's demo for this. Okay, hopefully I answered your question. If you've got any questions, please add those in. Was there anything else?
Nothing else in the someone asking about the slide deck, but you've already said that this will be sent round. But that's everything. So thank you very much for that, Andy. Much appreciated.
No problem. Thanks, guys, and I'll speak to you all soon. Cheers.
Bye.